Today we're going to practice stoichiometry problems, more specifically mass to mass. We first must make sure we understand what stoichiometry is. It comes from the Greek for measuring atoms. What we're trying to do in this problem is determine if we have a certain amount of reactant, how much product will we get? Or sometimes we will look at how much product that we need and try to determine how much reactant that it requires. This is the planning process for chemical reactions. So, in this problem example, we have 0.06 grams of aluminum and it reacts with sulfuric acid. We want to know how many grams of aluminum sulfate are produced. Well, let's look at our directions. First step, write the balanced equation. Luckily, in this example, we already have a balanced equation here. 2 aluminums, 3 sulfuric acid, hydrogen gas, and aluminum sulfate. Set up your problem. What do you know? What are you looking for? This is what students have the hardest part with, so we're actually going to write down what is known. What is known? We are given what is known, the mass of aluminum. And I'm writing down what it is, the quantity. I'm identifying the substance, and I am saying the quantity with the units. We know the mass of aluminum, and in this reaction, the aluminum is a reactant. What is unknown? What are they asking us for? Unknown. That is usually near the question word, just like English class. How many? How many grams or mass, of aluminum sulfate are produced? Unknown. Mass of Al2SO4, aluminum sulfate, and that's going to be in grams. So now we know where we start. Put the big smiley face here. In our T-chart, the start is that we have 0.06 grams of aluminum. Now we know where we are going now. We're going to the mass of aluminum sulfate. So let's see how many steps we need to take. We're starting with the mass of given, so we have to go to moles of given. That's one step. We need the mole ratio, the ratio of the moles of the given to the moles of unknown. So that's one step, two step, and then we need the mass of the unknown, 3 steps. We need to go from the moles of the given, mass of the given to moles of the given, use the mole ratio from the coefficients. This comes from the coefficients in the balanced equation. And then from the moles of unknown to the mass of unknown. So let's take a look at our T-chart. We have 1, 2, 3 steps. Step 1, mass of given to moles of given. Okay, this means that we need to go to from mass to moles. So 1 mole of aluminum. Well, we need the molar mass of aluminum because we have mass and we're going to moles. The molar mass of aluminum, looking on our periodic table, is 26.98 grams per mole. What this means is 1 mole of aluminum is the same as 26.98 grams. So we should be good to go on that. It's a single metal. All we have to do is look on the periodic table. We know we want moles and we want to cancel out the grams, and 1 mole of aluminum is equivalent. That's how we can use this for our factor labeling. This needs to be equivalent to this in order to multiply it by our original amount and not change the quantity, grams of aluminum. So far we went from, and if we did the math right now, we would have the number of moles of aluminum. But let's keep on going. We're going from moles of given to moles of unknown. So now we have to look at the coefficients in our balanced chemical equation. This is known. Number 2, we converted mass to moles. Step number 3, and we'll go back up to the top. Determine the mole ratio of given substance to the unknown, of what we know to what the unknown. Use a coefficient in the balanced equation. Place in the t-chart so your units will cancel. So let's take a look at our equation. We are looking at aluminum and the aluminum sulfate. There are 2 moles aluminum for every 1 mole aluminum sulfate. That is a 2-to-1 ratio. We could put it in, there we go, 2 moles of aluminum for every 1 mole of aluminum sulfate. Now that's the ratio, and we could set it up 1 or 2 ways. 2 moles Al over 1 mole Al2SO4, or 1 mole Al2SO4 over 2 moles aluminum. Well, let's take a look. Up here, what we are trying to do is go from moles of our known quantity to our unknown. So we want to end up with moles of our unknown. We want to end up with moles of the unknown on top. So we're going to use this one. If we use this, the moles of aluminum wouldn't cancel out. So let's go up here and fill it in. 1 mole Al2SO4 to 2 moles Al. That's our ratio. All right. So let's look at our next step. Convert unknown from moles to mass or volume or particles, whatever is asked for in the question. That's why we have to analyze a question. Our unknown is they want mass. So in the end, we should have some kind of grams here, and we want to cancel out the 1 mole Al2SO4 because we are converting from moles to the grams. So let's see, so far we've been able to cancel these grams, cancel out these moles, nice, and also cancel out these moles, but we still have to do this one last thing. We need to know what is equivalent in grams to 1 mole of aluminum sulfate. Well, we need the molar mass because that's what is equivalent to 1 mole of aluminum sulfate. I calculated out the molar mass just like we've been doing. 1 mole of aluminum, 1 particle of aluminum. There are sulfur, we have 3, and oxygen 12. That's a harder one. There's 4 of them in our polyatomic ion, but we have a subscript of 3. 3 times 4 is 12. I take all the molar masses from the periodic table, I multiply them by the number of atoms, add them up, and I get 342.15. And from the periodic table, that's atomic mass units. But what this means is 1 mole of aluminum sulfate is 342.15 grams. And that's what we put right here, 342.15 grams. And that is what goes in there. So everything canceled except for the grams. We have done all the steps except for the last step, the hardest step, for me, is putting this in the calculator. What you're going to do is you're going to multiply everything across the top, and then take that, you're going to multiply everything across the bottom, and then you're going to divide the difference between the two products. Everything across the top divided by everything across the bottom. And your answer on this one should be 0.38 grams. And I ended up with the same number of significant figures as I started with. And that is how you would do a stoichiometry problem, mass to mass. We determined what was known, we figured out what was unknown, how many steps we would need to take, how to set up our unit conversion factor, so the amount on the top is equivalent to what's on the bottom in each of these, setting them up so we could cancel the equation, the unit we wanted to get rid of, and have the one we desired on top. And so in the end, we ended up with mass in grams as our unit. And that's how you do it.